Hi everyone, today we're going to be doing lesson 9-3, using mental math to multiply. Remember, mental math means doing it in your head. So here we go. Our first problems are some extended facts. So you want to be looking for the basic fact hiding inside each of these extended facts and use that to help you. So I'm going through right now and I'm doing some underlining, and hopefully that will help us as we go on. We know 5 times 4 is 20, so 5 times 40, 200. All right, 3 times 6, we know that, so 3 times 60, 180. 250 divided by 5, that's going to equal 50, because we know 25 divided by 5 is 5, so 250 divided by 5 is 50. All right, our next one, 7 times 70, 490, 4 times 80, 320, 420 divided by 6, that's going to equal 70. All right, moving on. We're going to want to go ahead and open up our math journals, but I did do you guys a favor. I took a little screenshot of the information that we need, so feel free to just follow along with what's on my screen and use like a scrap piece of paper or a whiteboard to do this problem. It says, look at journal pages 277 and 278. I already grabbed the information we need from those two pages, so don't worry about turning to those if you don't want to. Could 5 blue jays have a greater total mass than an Atlantic puffin? So I took the pictures from those maps. I have the blue jay and the Atlantic puffin. We want to know if we had 5 of these blue jays, if it would be possible for the 5 blue jays to have a greater total mass than one Atlantic puffin, because it says an Atlantic puffin, so that's 1. Could their total mass be less than that of an Atlantic puffin? So we want to know if it's greater than, or we want to know if it's less than, and we are not sure about that. So we know we're working with a total of 5 of these blue jays versus 1 Atlantic puffin. So for 1 blue jay, the question is, how much does it weigh? And it weighs 70 grams to 100 grams. For the Atlantic puffin, we're talking about 400 grams to 650 grams. So we want to think about this. Is it possible for 5 blue jays to weigh greater than or less than 1 Atlantic puffin? Go ahead and push pause while you try to tackle this problem, and then we'll talk together. All right, let's first try this. We know that if we have 5 blue jays, we could do 5 times, and let's pretend that these are the top part of the blue jay weight category here. Let's pretend they each weigh 100 grams. Well, if they each weigh 100 grams, 5 times 100 equals 500 grams. Now, is that greater than an Atlantic puffin? Yeah, because the Atlantic puffin could only be 400 grams. So yes, it is possible. But let's try the low end of the spectrum. If we have 5 blue jays and they each weigh 70 grams, if we do 5 times 7, we know that's 35. So 5 times 70 would be 350 grams. So let's look at that, and let's compare that to the low end of the Atlantic puffin. Could the 5 blue jays weigh less than 1 Atlantic puffin? Yes, if they weighed the 70 grams. The strategy that we're using here today is using mental math, finding those extended facts inside, the basic facts inside the extended facts, and that helps us to be more efficient when we are doing our multiplication. So now we're going to go ahead and we're going to go in our math journals for real this time. We'll need a pencil, and we're going to go to page 281. I'm going to work through these 3 with you, and then you're also going to have page 282, and I will tell you which numbers we're going to work on in there today. So hopefully you've grabbed your book And you turn to the right page, and here we go. Solve each number story in your head. Use number models and words to show your thinking. The mass of one American white pelican is about 8 kilograms. What is the mass of 16 8-kilogram pelicans? So I want to know what your thinking is. How many pelicans are we talking about here? Well, we know from the story that we're talking about 16 of these pelicans. My question for you next is, how much do each of those 16 pelicans weigh? And the answer is 8 kilograms. So we would want to multiply by 8 kilograms. Now you might be looking at this problem and thinking, I can't do that. I can't do 16 times 8. But I'm going to remind you that yes, you can. And we're going to use a strategy here to help us figure that out. We can do one of two strategies, and these are the strategies that we learned earlier in the year. They work with these types of problems too. The strategy that I'm thinking of first is the doubling strategy. And I know that 16, if you break it in half, it's 8 and 8. So what you could do is you could say 8 times 8 equals, and then do 8 times 8 equals, and then if you add those together, you're going to get the total for 16 times 8. Another strategy that you could use, so that was doubling, another one could be break apart, and maybe you do 10 times 8 equals, and then you do 6 times 8 equals, and then add those together. So when you're talking about this, my thinking, you're going to want to kind of explain to me which strategy you're going to use. Remember, this one over here is called doubling, and we learned about this earlier in the year. This is not new information. And over here, this is called break apart. Remember, doubling only works with when you can break it exactly in half. Breaking apart, sorry. All right, so there's the first one. So let's go ahead and do that. We know 8 times 8 is 64. So 64 again, and then add those together. Or over here you could do 10 times 8, 80. And we know 6 times 8 is 48. So either of those would be great methods to do. I'm going to move on. I'm guessing that you can fill that kind of stuff in there that's left. All right, number 2. One blue jay has a mass of about 75 grams. So that's like an approximate weight. What bird could have about the same mass as 6 75-gram blue jays? So we know one blue jay has a mass of 75 grams. We want to know what 6 blue jays' mass would be if they each weigh about 75 grams. So we're going to do that we have 6 of these 75-gram birds, okay? So for this one, I'm going to definitely say let's try break apart, and let's do 6 times 70, and then 6 times 5. And then when you finish both of those, put them together, and that's going to help you with the answer. Now, the next step gets a little bit tricky. You're going to get an answer down here of a weight, and then you're going to have to go in your math journal to page 277 and 278 because you need to figure out what bird has the same mass that would go there. And I'll give you guys a hint. The answer, there's actually 2 different options. But your answer down there is going to be a bird. It's not going to a bird name. It's not going to just be a weight. Okay? Number 3. One house sparrow has a mass of about 35 grams. So we're talking about a house sparrow. How many blue-crowned moths together would have the same mass as 5 35-gram sparrows. So we need to figure out, first of all, how much 5 35-gram sparrows would even weigh. So remember, we're going to put 5 first because we're talking about 5 of them. And they each weigh 35 grams. So let's do that break apart strategy. I love the break apart strategy. It's so great. And we'll do 5 times 30. And then 5 times 5. And you guys are really good at these kinds of problems. Add them together and then let's figure it out. Well, 5 times 30 is 150. 5 times 5, 25. Total, oh my goodness, there we go. Total would be 175 grams. So you need to go back to that math journal, page 277, 278, that has those pictures of the birds on them. And you need to figure out how many of these blue-crowned, let me circle it in a different color, blue-crowned motmots, how many of them would you need in order to have the same amount of weight right there? So you're going to go back to the math journal pages and look for the blue-crowned motmots and figure out about how many would go there. So for your my thinking, don't forget, you're going to talk a lot about either the break apart or the doubling, like whatever strategy that you used. Okay. Go ahead and wrap that up. Push pause while you're doing that, or go ahead and repeat the information by kind of scrolling back and listening to it again. I'm going to go on to the next page, and we only have 3 that we're going to do. So today we're going to talk about number 1, number 2, and number 5. So you may skip 3 and 4 today. All right, number 1 is a review. We're going to share $57 equally among 3 people. And remember, you use $10 bills and $1 bills. And then you can have a letter in here that stands for whatever is missing there. You can go ahead and draw a picture in here. I think that's helpful. And then I would maybe do those rectangle boxes to stand for the 3 people. I think that that's helpful and really lays it out pretty clearly for you. Martin poured 24 liters of water into 8 same-size containers. How many liters of water did each container hold? So you're going to be starting with 24 liters, dividing them into 8 same-size containers. How many liters did they each hold? And then problem 5 has to do with number 1. Look at problem number 1. If 4 people share $57, would they get more or less money than 3 people who would share $57? How do you know? You don't even need to do the math here because you know in your head, if you're sharing $57 between 3 people, so here's your 3 people, are you going to get more or less money? Are you going to get more or less money than if you shared it with 4 people? And you guys totally know how to answer that. I know you're going to do great. All right. Feel free to pause this right here, fill out the rest of this paper, and then move on. Or feel free to grab your home link. We're going to go over that right now. These are just like what we just did. It's so lovely. The mass of 1 California condor is 9 kilograms. What's the mass of 12 9-kilogram California condors? You can do that. Workspace in here, kind of show me what you're thinking. Show your number models or words, but I want to see what was going on inside your head on the paper. Don't forget units. The mass of 1 mountain bluebird is 25 grams. What's the mass of 7 25-gram bluebirds? Same deal. Whatever you're doing in your head, put it here, and then here's your unit. Number 3, explain to someone at home how you can use the break apart and doubling strategies to solve the problems with larger factors. And that's totally what we were just working on together on page 281. You guys are going to do great on this, and I'm super proud of you. Keep up the good work. Bye.